on my, yeah, I'm just preparing for the live stream. There also it will be there, but something goes wrong, it is better that we have some recording with us.
Sure, ma'am. Thank you, ma'am. Thank you. Can we start, sir? Madhusudan, sir?
Yes, ma'am. Please start.
Yeah. Good evening, everyone. On behalf
Just
of
a
Physics
minute.
Department. Yeah, ma'am.
Yes, madam, you can start now.
Yeah. Thank you. Thank you, ma'am. Good evening, everyone. On behalf of Physics Department, St. Francis College for Women, I, Dr. Usha Pravina, Head Department of Physics and Dean of Science, welcome you to today's lecture on Quantum Science for Sustainable Tomorrow by the esteemed Professor P.K. Ahluwalia. Professor Ahluwalia is a renowned physicist and academician with a distinguished career at the Himachal Pradesh University. His work has been widely recognized and he has been invited to serve on various advisory committees, including the Himachal Pradesh Public Service Commission and the Private University Education Regulatory Commission. His notable achievements include over 205 publications and 2,601 citations, and research focus on electronic structure, density functional theory, and 2D materials. Sir guided 18 PhD students and 34 MPhil dissertations and authored 3 books on computational physics. He's held leadership roles, received prestigious awards like Commonwealth Academic Fellowship 97 to 98 at the University of Edinburgh, United Kingdom, recognizing his academic excellence. Best Teacher and Academic Administrator Award 2012 from Himachal Pradesh University, honoring his dedication to teaching and administration, and Environment Leadership Award in 2017 from the Department of Science and Technology, Government of Himachal Pradesh. Demonstrating his commitment to interdisciplinary knowledge sharing and community engagement, he has organized 15 seminars and conferences covering diverse areas including physics, IT, quality assurance, library science, and community service. With a teaching career spanning 35 years, Professor Ahluwalia is currently an adjunct faculty at UGC Inter-University Accelerator Center, New Delhi, and IIIT, Vadodara. His research areas include condensed matter physics and physics education research. It's an honor to have Professor Ahluwalia sharing his expertise with us today. Thank you for accepting our invitation, sir. Please join me in welcoming sir. Over to you. Please, sir.
Thank you very much, ma'am, for your kind words. And I'm very happy to be part of this program. And
One second, sir. Somebody's mic is on.
Thank you very much, ma'am. And I'm very happy. Today is a very different kind of a seminar because the title of the seminar is very different because it is expecting something beyond what we normally do in physics as such in the classroom. But I think in that sense, it is very enlightening also that we will talk about the relationship of quantum science with society. I think it's not what you can call as a kind of a secret. Everybody knows that how in the last 100 years, the society has been benefited by the development and the evolution of the quantum mechanics. So the title of the seminar is Quantum Science for Sustainable Tomorrow. And when we are talking about sustainable tomorrow, it is not that we are looking forward to some big technology, but we are looking forward to that how whatever we know about quantum science can help us meet sustainability goals. Keeping that in mind, I have made this presentation, and hopefully it will enlighten us about certain efforts which are being made throughout the world. So I believe that you will find it slightly different from the fact that there is not much what you can call uh, as what we can say is this is not something which we will be finding normally being discussed in classrooms also. So my effort will be that I should try to give you the flavor of what we are actually finding as very interesting for us to look at in future. So the title of the talk, I have extended it slightly, Quantum Science for Sustainable Tomorrow. And what I wish to talk to you in this presentation is a case study of CERN initiative, which is directed towards what we call sustainability goals. I think everybody who is sitting in this audience is aware of CERN as a particle accelerator, big science lab, and that has very many initiatives which have changed us also. One of the very big initiatives which emerged from CERN labs was the starting of what we call today as World Wide Web, WWW. I hope many of you sitting in this audience must be recognizing this man sitting in front of a computer. He is Tim Berners-Lee. He is the man who actually wrote a proposal for the director of the CERN. The title of the proposal was very simple. It was called Information Management System. And the motivation for this had actually come from the scientists working in CERN. One of the scientists approached him and said that is it possible that if we are reading a research article and if there is any reference which comes there, if I click it, I should be able to see that reference and read it. He smiled at it and he said, yes, I already have that technology with me. And I think maybe you don't know it. I keep track of all the complaints you send me in a similar fashion itself. So that scientist suggested him, why don't you write a proposal to the director? So he wrote that proposal, which I just mentioned. Director went through it and he wrote a very interesting remark on top of that. And that was interesting but confusing. And from here you can see how the name of World Wide Web must have emerged, because web is also a very, very spider web, if you imagine, is a very interesting, intricate, complex structure which spiders actually weave. And today we know it is the same web which is providing us such a reach which nobody had imagined maybe till about 1990 itself. But after that, things changed. And today we know that it has become a kind of a lifeline for us for many things. If you ask any common person for what purpose you are using internet or websites, he will tell you number of things which have influenced his or her life. For example, your banking, your distribution system, everything which is happening in terms of communication today is via that web only. We have such wonderful applications as, say, WhatsApp, on which we can instantly communicate with each other, not only in terms of chats, but also in terms of video chats. So this has really changed the world. So this initiative once again has come from CERN, and that is what I intend to discuss with you today in this particular lecture. Now, we should also remember one thing, and that is that this initiative is very interesting in the sense that it is going to uh, impact our life in a very big way in near future. So this initiative has been started as an open quantum institute in CERN. CERN is known for its open source initiatives. This World Wide Web, which was initiated by Tim Berners-Lee, who was basically a particle physicist, but was also having the responsibility of looking after the network of that lab. When he was asked that here is an opportunity for you to earn money out of this uh, wonderful invention which you have made, he refused to submit to that kind of a thinking. And he said, no, I don't want to earn money. Rather, I would make sure that it is made available to everybody. And but for that futuristic thinking, maybe we would have been not getting the kind of openness which we get on the World Wide Web itself. So this initiative of Open Quantum Institute is an initiative of CERN, which is a kind of a multilateral science diplomacy. And I hope as I will go further, you will appreciate what I'm trying to tell you. And all those things, we talk in our society also of inclusion, of availability, no exclusion, gender equality, and something which should benefit humanity are part of this particular program. It's a big, big global initiative. These days, we have been passing through that time when the Nobel laureates received their Nobel diplomas of winning the Nobel Prize. I hope we must remind ourselves that when Alfred Nobel actually made a commitment for that prize, he said this prize should be given to people in physics, chemistry, biology, or what they call medicine and economics, or on peace, what benefits humanity. And I think that is the key initiative, key idea behind this Open Quantum Institute also. Please don't forget that when we are saying open, it is understood that it has to be a collaborative effort. Collaborative effort between one, academia, technology companies, the private sector, diplomacy, philanthropy, and global citizens. So it's for everybody whom we are actually looking at. And this is the set of few objectives which have been kept for this particular program. First is accelerating applications for humanity. This is the first thing which goes into this. What we want to do is we want to explore quantum computing's potential to drive progress on critical global issues like health, food security, and environmental sustainability. Second is access for all. That is, provide cloud-based access to quantum computers and simulators, ensuring inclusive participation in the quantum revolution. Already we are hearing that people have come into a kind of a denial mode where quantum computers and simulators are being restricted for usage by everybody. So this program says, no, we want to ensure inclusive participation in this quantum revolution itself. Third thing which is there is advancing capacity building. Now, what is the meaning of this? We know that this kind of a technology, which we call as quantum computing, this is something which is going to impact everybody. And everybody needs to, get ready to extract maximum benefit out of it for the benefit of humanity itself. So when we talk about capacity building, means that we should tell researchers what they should do. We should tell policymakers that what kind of rules they should really make. And we should make sure that those places which are quantum underserved regions, like in Africa, in Asia, or in many other continents, they should be provided with the knowledge needed to engage with the quantum technology. I think many of us who are today using World Wide Web, we have passed through those stages where we always used to say this technology, World Wide Web, there are certain people in society who are have-nots. So how we should include them. And now we are at a stage where there is a complete saturation of percolation of internet in our own country itself, and the cost is also quite reasonable so that people can afford it. Then there is another thing which is there. There is a new term you will hear about it: activating quantum diplomacy for the sustainable development goals of United Nations. So this actually requires that the statesmen and the leaders of the world, they come together on global platforms, have global dialogues on quantum computing awareness, shaping policies that align with responsible innovation and sustainable development. So, time and again, you will hear this term sustainable development in this lecture. So, this Open Quantum Institute focuses on these sustainable development goals. And what they are doing now is they are developing use cases for telling people that how quantum computing can be used for this particular purpose. And they are providing us some case studies, use case studies in health, energy, climate action, clean water, and food security. I'll tell you how such initiatives have already been taken in OQI itself. So this program, to begin with, has been initiated from 2024 to 2026, and it is supporting projects targeting these use cases and laying the foundation for the next phase of the program itself. So already we are finding they have identified context in which we need to do work. They have brought together the stakeholders who are going to benefit out of it. They have brought together researchers who are going to work on it. And I feel that the audience who is sitting in this particular session will find it very interesting to note that these are the opportunities which are waiting for us in future to be a part. And if we are in the physics departments or in chemistry departments or in science departments, I think we can have an advantage and an edge as we proceed further. So how this OQI works? So as I said, it supports use cases addressing global challenges using quantum computing. Now, use cases means what? We identify a context in which we want to really use it, and then we try to identify what are the challenges. Then we also try to identify what are the challenges as far as implementation in quantum computing is needed. And a kind of an ideation to proof of concept actually has already started happening. This OQI offers a neutral platform for collaboration between quantum experts, United Nations agencies, and NGOs. So if you are thinking about starting an NGO around quantum technology, I think it is high time that you catch up with these ideas to be ready to have an edge in taking advantage of these possibilities. So what has happened in the last about 2 years, that for sustainable development goals, they have focused on a few uh, sustainable development goals. Goal 2, Goal 3, Goal 6, Goal 7, Goal 12, and Goal 13. Goal 2 is zero hunger. Goal 3 is good health and well-being. Goal 6 is clean water and sanitation. Goal 7 is affordable and clean energy. Goal 12 is responsible consumption and production. Goal 13 is climate action. Now, if you go through these things, you will immediately see that these are the urgent needs which we really need to look at as far as our society is concerned. We don't want that anybody should die of hunger. We want that everybody should have good health and well-being. Clean water is something, if it is provided, we find that it can take care of diseases. Sanitation is another thing. We are talking of Swachh Bharat so much. In the last 10 years, we have been really talking a lot about it. Affordable and clean energy, you know that energy is costly. Government gives lots of subsidies so that everybody is able to afford it. Responsible consumption and production. I think this indicates and tells us about how we have to take care of our nature and natural resources. And we are to consume things in such a manner that things happen into a kind of a recycling mode. Climate action is already knocking at our doors. We are finding that floods have become very common. Those places where never used to be floods, they are being inundated by water. The rainfall is also very high in certain times of the year, and sometimes there are droughts. So, in looking at these uh, sustainable development goals, we are looking at quantum approaches. And what are those approaches which we are focusing on? Simulations, optimization, machine learning, and linear systems of equations. Now, we must really appreciate and understand that simulation we talk about even now when we have classical computers. We have also been solving optimization problems. Machine learning is also, taking big leaps, and linear systems of equations are already there, which we people have been using. So, what is there when we are talking of quantum approaches? The reason which is bringing us to this kind of an idea is that the problems which are being faced by us today are very, very complex. And because of the complexity of these problems, we find that the classical computers can do simulations, but may not handle the complexity of the problems itself. Similarly, we may find that optimization requires the kind of parameters which are very, very large, which needs to be satisfied. Machine learning is getting very interesting to take advantage of those things which have a lot of predictive value also, and we can really go ahead. So what OQI has been doing is it has been publishing white papers. And this lecture basically is based on one such white paper which I came across on United Nations International Year of Quantum Science and Technology itself. And that is how I came to know about what I am actually discussing with you. And you will find that in each of these case studies, there is a collaborative work which goes on with different countries coming together having similar problems. And the idea is to solve these problems, we have to see a kind of strategy to explore quantum computing applications. Now, these development goals, I hope you can see this slide very, very clearly, are 17 interconnected goals adopted by United Nations in 2015 to achieve a more sustainable and equitable world by 2030. Target is very near to us. Can quantum computing make a difference? That is a big question. And these sustainability goals address challenges like poverty, like hunger, like climate change, inequality, and aiming to ensure prosperity and peace for all. So when we are really looking at these carefully, you will find there is first goal is no poverty, zero hunger, good health and well-being. Quality education is a very important part of it. Gender equality, clean water and sanitation, affordable and clean energy, decent work and economic growth, industry, innovation and infrastructure, reduced inequalities, sustainable cities and communities, responsible consumption and production, climate action, life below water, life on land, peace, justice, and strong institution, partnership for the goals. These are the 17 goals. And it requires a kind of collective effort. So when these were identified, a universal call to action for countries, organizations, and individuals to work together towards a better future was given. And that is why today we are discussing all these things. Now, what is the methodology which they adopted for working in this particular fashion? They identified a methodology in which there are three chambers. You can call those as chambers or verticals or sections. One is identification of a context. So a very clear-cut idea about what is the problem, in what context we are talking about. Then if we want to handle that, then what are the computational challenges which we are facing in the context of the classical computers itself, which are easily available to us. And then if we look for quantum solutions, what can be the potential impact on that? So when we are looking at this white paper, you will find that they talk in the context of these three things for every problem in the context which they have identified. And they also try to convey that once we adopt quantum computing, we will find that we will have a major advantage over classical computing in certain areas. For example, we can have speed up of the computations. Quantum computers can process certain calculations much faster than classical computers, thanks to quantum parallelism and entanglement. I hope audience who is sitting here must have been hearing about these words as superposition, entanglement, and many other terms which are often discussed in typical quantum mechanics environments. Then second thing is it is fit for complex problem solving, because quantum computers can tackle complex problems that are currently unsolvable or take a long time to solve classically, like cryptography, optimization, and simulation problems. You already must be hearing about cryptography a lot. So this is what is basically the kind of advantage which we will get once we start thinking in terms of solving these problems using quantum computing. And it is expected that this quantum computing will shine in the areas like cryptography, breaking some encryption algorithms, optimization problems, logistics, finance, simulations, for example, chemistry, material science, machine learning, and creating some algorithms, etc., etc. But we have to remember one thing, that quantum computers are not necessarily better for everyday tasks like browsing of the internet or office work. They are more about solving specific complex problems. So we will find that once quantum computers are available to us, and they are available right now, it is not that they are not available, we will have to sit down and see what kind of specific problem we need to really look at, which we can solve on that quantum computer. And that is why these white papers are very interesting papers to look at, that how we are looking at using this quantum computing to solve and tackle the problems of the world itself. Now, let us try to understand a bit of advantage which quantum computing gives us. and how in going from bits to qubits, it becomes a game-changing advantage for complex tasks. One is qubits can exist in multiple states because of this idea of superposition, allowing quantum computers to process vast amounts of information in parallel. So you know that superposition of quantum states is a very well-known phenomenon, and we make use of it. But when we are using uh, these quantum computers, we are not just using 0 or 1, but we can use, say, 0 and 1 both simultaneously, depending upon what weight you would like to give to 0 or what weight you would like to give to 1. So this is a very big advantage which actually happens. Second advantage which people see is entanglement. So these qubits can be connected, enabling quantum computers to perform complex calculations exponentially faster than classical computers. And this entanglement happens between two entities, like, say, for example, two photons, even when they are very, very far apart. Imagine how far apart it can be. At the scale of the universe, you can imagine that kind of a thing. Then quantum parallelism implies that these qubits process multiple possibilities simultaneously, making quantum computers ideal for tasks like cryptography, optimization problems, simulations, and machine learning. And this quantum advantage enables quantum computers to tackle complex problems that classical computers normally cannot handle. So these are some of the case studies which uh, Open Quantum Institute has developed as a portfolio. Now, in the first case study itself, you can see India is also one of the participating countries. These flags actually tell us which of the countries are participating in this. Now, for example, when we want to get rid of hunger, I think we must ensure that we have at the farthest end food delivery. So that means food supply chain has to reach the one who doesn't have the food. And in the route planning of this food delivery in underserved regions impacted by climate change or other crises becomes very, very crucial. So what is at the heart of this particular problem? You will find that at the heart of each of these problems, they identify that what needs to be done. And they have given a single word to satisfy that what is to be needed in this particular challenging problem. And that is that it is an optimization problem, which we really need to look at. Then we have plant genomics. And plant genomics actually associate itself with quantum computing solutions to improve, say, wheat, corn, and soya yield by targeting gene editing. And I think this is something which they have identified will require machine learning. Very nice. Then becomes sustainable food production. That is improving sustainability of global food systems by making them more resilient to climate change through a quantum optimization solution to produce more nutritious food locally in less land. No, you know, as the population is increasing, the land is shrinking. And this is a very crucial challenge for us to look at. Once again, it is an optimization problem. Now, if we try to look at the next problem, accelerating novel antimicrobial discovery. Now, this is a very important problem where we would like to have a situation where we should have lower resistance to drugs. So if we are to do a kind of a solution or bring a solution of this in front of us, then you will find that once again, quantum machine learning solutions can really help us to move forward. Then predicting gastrointestinal cancer. Again, in this case, quantum machine learning solution is being looked into. It has not as yet come, but this is a kind of a problem on which people are trying to focus to improve accuracy of gastrointestinal cancer diagnosis and speed up medical treatment and prevention. This is again the third sustainability goal. It really comes under that issue of improved health, etc. Then we have women's healthcare. Quantum simulation for the molecular interaction of the biological targets and drugs involved in the treatment of endometriosis, perimenopause, and menopause. These are very crucial parameters and points which come under women's healthcare. And here, people are looking forward to the quantum simulations for looking at this particular problem. Then we also are looking for a very interesting case where we want to look at drug metabolism design itself. You must be knowing that whenever we sometimes take drugs in good faith that this will give us a benefit, but there are drug reactions which can be fatal also. How to really bring down this kind of a adverse drug reaction scenario. This is the most important part in this, and this also involves what we call quantum simulation itself. Now, this is very interesting, eliminating forever chemicals from water sources. Now, we know that we would like to really do something on a quantum computer, a quantum simulation, so that those chemicals which live forever in water, they get decomposed. For example, polyfluoroalkyl substances for more efficient removal in water, limiting physiological and environmental harm is a very crucial problem. How can we eliminate that? Again, we are hoping, and the kind of case study which has been done here under this OQI initiative, we are finding that it is very well identified. Then water leak detection. Many a times, we hear that it is not that water is less. What we find is that when this water is sent through pipes to places where it is to be used, on the way, there are water leaks which we cannot detect so easily. Can we really have optimally positioned sensors to detect these water leaks and save water in urban water systems itself? And people are saying, yes, it is possible, provided we once again try to look at it as a problem which is an optimization problem, and it can be solved using machine learning. Then molecular docking to clean up pollution. So it is like this. People are saying that if you want to get rid of pollution, you would like certain molecules which we can dock in a chemical process, and they will help us in removing the organic pollutants in water. I hope you must be observing that all these goals which are being discussed, maybe on the face of it, we may say, what is there new in quantum computing? The new thing is that the kind of complexity these problems involve, it is not very easy to take care of these problems or solution on a classical computer, which are good and running around. Water resource management. It involves quantum fluid dynamic solutions to model aquifer systems, prevent and monitor contaminant breakthroughs, and assess impact of climate change on water reservoirs itself, or the impact of shrinking glaciers on the water reservoir system itself. Then you must be hearing two things which are very interesting happening around in the country these days. We are trying to switch over to what we call the sources of energy which are inexhaustible, like for example, solar energy, or like example, wind energy. Now, suppose we want to have a wind farm or a solar farm at some particular place. How can we maximize the power produced in that particular farm itself? I think before really having that kind of a layout of turbines in a wind farm, we will do a simulation which requires once again quantum computation, because it is again a very complex problem, so many parameters need to be taken into consideration. There are so many things which happen around over the year that we need to really see that we are aware of the impact of all those things in designing these wind farms or solar farms. So it's again an optimization problem which we are actually looking at. Then you know that when energy comes to our homes, there are grids via which the electricity reaches us. Maybe in my home, the electricity which I am getting is coming from, say, Arunachal, or from Himachal Pradesh. This energy is going to some place, say, in Gujarat itself. Now, this kind of transport of energy on these large energy grids require smart grid management solutions. We use those kinds of solutions today, but sometimes you will always find that the grids trip and a whole region goes into darkness. How to handle such situation? Again, people are saying quantum computing is a very interesting and nice way to look after and solve this kind of a problem. Now, I will just discuss one case study in detail, that where I will try to describe the context. Then we will try to look at the challenges involved. Then we will try to see what is the quantum solution which is available to us and where quantum computing can help us. So the context is drug metabolism design. Now we know that this adverse drug reaction are a major health issue causing significant morbidity, mortality, and economic burden. And these ADRs are responsible for sixth leading cause of death worldwide, affecting vulnerable populations like children and elderly. This is something very, very scary, in fact. Then pharmaceutical companies also face significant design challenges in drug development due to these ADRs, leading to increased costs and timelines. So we have to go over a long period of time to make sure that yes, the drug which we are going to release in the market is not having these kinds of dangers, and there are no typical health issues involved with the typical drug which is being sent to the market. So we have to have accurate prediction of drug metabolism to reduce these ADRs and improve drug safety. Now, we can shrink these timelines and the costs by making use of quantum simulations of electronic structures. Now, this term electronic structures is very interesting. You will hear a lot of people do electronic structure calculations using quantum mechanics, because the models which we use there for doing these calculations are quantum mechanical models. But as the size of the system increases, we find that we have a limitation of getting valuable outputs out of these simulations itself. So there are certain limits up to which we can go, and then we will have to really come back. So this is the context in which we want to work. So what is the computational challenge? In fact, this involves certain typical type of enzymes and multiple reaction pathways. The name of this set of enzymes is known as cytochrome P450, CYP in literature it is normally written. We had classical computational methods to do all these things, for example, DFT, coupled clusters, but these face limitations. Computational cost increases like anything. Accuracy is also not there. The most important thing in this is calculating the reaction rate. And these classical computational methods are very inefficient in that case. And when the system size increases, there are scaling issues which come into picture. So currently speaking, these methods cannot accurately model this CYP enzyme active sites, limiting predictive power potential. So if we have to really go beyond this, what we need to do? We have to go to a quantum solution. And we find that quantum computing can simulate strongly correlated electronic states with chemical accuracy, overcoming classical limitations. So, what are the potential benefits which are there out of it? We get improved accuracy in predicting drug metabolism, enhanced understanding of CYP enzyme mechanisms, optimized bioavailability and reduced toxicity risks, safer and more efficient drug development cycles, potential to outperform classical methods in simulating electronic structure. So, what are the possible things which we find are available to us in the quantum solution? It is variational quantum algorithms for adaptive multi-wavelet representations and quantum phase estimations for accurate molecular energy levels. Now, you will find these terminologies also become a bit complex when we are looking at it. But the moment you hear about, say, molecular energy levels, you know that somewhere in between quantum mechanics is playing its role. And that is what we need to really keep in mind. So, what I have discussed, and I would like to really hear from you your ideas, your questions. What are the key takeaways? Open Quantum Institute initiative offers several advantages. One is democratizing access. OQI provides cloud-based access to quantum computers and simulators, ensuring inclusive participation in the quantum revolution. So suppose in near future, you go and study, say, physics or chemistry, and if you are having those tools which you have learned there to do quantum computation, I think you will find an advantage in the quantum workforce itself. And when we are saying it is democratic, once anything is on the cloud, it is very easy to make it accessible to different people. Then accelerating applications, because this open quantum initiative brings together researchers, developers, policymakers, United Nations agencies to explore how quantum computing can drive progress on critical global issues such as health, food security, and environmental sustainability. We can really put our foot on accelerator to arrive at possible solutions in very near future. Third thing which is there is lot of capacity building is needed for this particular purpose. When we are talking about this capacity building, that means we must equip researchers, policymakers, and quantum underserved regions with the knowledge needed to engage with quantum technology. Also, this has led to a very interesting field which we are calling as quantum diplomacy. We are at a stage where we must realize that this kind of a diplomacy of science has been in place quite a bit. The day nuclear physics came on the scene, the day nuclear bomb was made, the main thing which happened was that leaders of different countries started talking with each other how to curb making of these weapons of mutually assured destruction itself called mad race. So we are finding that when we are looking at the benefits which we can have out of quantum computing itself, we need to bring together global leaders for global dialogues, for multilateral governance of quantum computing, shaping policing, and then aligning these with responsible innovation, safety, and sustainable development. So the moral of the story is that by facilitating equal access to cutting edge technologies, OQI aims to accelerate the development of quantum solutions for societal challenges, ultimately contributing to the achievements of the United Nations Sustainable Development Goals. Now, I would also like to underline here, particularly a young audience is sitting in this particular session, that we must appreciate and understand one thing, that basic sciences have a great role to play when we are talking of these kinds of open quantum initiatives. if you come with a clear uh, goal in your head that you are going to continue with it, and what is the kind of skill set which you would like to have, you will find that you can achieve a lot in terms of getting a very good job in future also. I am seeing, because of the various initiatives which are coming up here, that anybody who is coming to these kinds of initiatives will find a very similar career which happened when World Wide Web came and we started seeing many computer companies hiring so much people. So here things are going to change. We are not going to talk about, say, engineers being hired, but we are going to talk about quantum ready workforce will be required in future. And for that, maybe the toolkits which you need to have is knowledge of good programming language like Python. You also need to have a knowledge of working on the simulators of quantum computing. You also need to look at how the knowledge which we have of material science can be used to predict better materials in future using machine learning and this quantum computing. So I hope within the scope of the title of the lecture, I try to share with you whatever I have learned in the last 1 year, in fact, because this year has been a great experience for us in IAPT. We had very interesting initiatives which we had, and we came uh, in touch with agencies like United Nations International Year of Quantum Science and Technology Group. And I would very much recommend that you please go and visit that particular website and see that what is happening. This lecture which I have prepared is a result of that kind of an accessibility which was available to me on that site itself. And the link for that is given here. You can just click a picture or take a screenshot. Also, on that website, you will find that there is a very interesting educational repository which is available, which is telling us what are the things which you can really uh, uh, see, where you can get diplomas, certificates, or degrees, or maybe you can learn beyond what you are learning in your classroom itself. And please don't forget, all this is coming from CERN, which has a credibility of being the game changer in the science scenario, and particularly in physics. And I would also underline that all such kind of shifts which happen, once they happen, uh, they are there to move ahead and change the things very rapidly. So we should not be caught napping. We should prepare ourselves and see to it that things are done in a systematic fashion. So if there are any questions, I will be with you. You can just uh, ask your questions. I am back with you, and hopefully you will have good questions because once the questions come, that also helps us to learn the things. So thank you very much. So I'm stopping sharing, and
Yes, please.
hopefully I have justified the topic which was given to me. Thank you.
Yes, sir. Yes. Thank you for your thought-provoking lecture and a beautiful insight, full case study of this OQI, sir. I have a doubt, sir. Like now, when we have this transition from the present computers to the supercomputers, what we talk about the quantum computing, all that, how would you think that transition would happen, sir? Will
It is
it
like
be?
this. It is like this. When we are talking of classical computers, they are available to us on our tables or our laps or on our palms. Mobile is one such computer itself. Now, these are going to be like gateways to the quantum computers, which will be available to us on the cloud, right? And if we want to use these, it's like, becoming part of that network of computers. And this network of computers is not just a network of computers, it is a network of human beings. We must not forget that, because at the back of every computer, even if it is a quantum computer, there is somebody who is needed to think about the algorithm which has to go inside it. That is why these case studies we are talking about, that okay, we want to solve this problem. This is the context. What is the challenge? What is the complexity? Why we are not able to solve it on a classical computer, and why we are feeling that the quantum solution is a challenge. So you will find already, IBM, for example, has been providing a platform of, in the form of quantum simulators called QuizKit. And there people can go and learn these quantum computing fundamentals and move ahead. Though there has been a lot of talk about that no, IBM may not provide it in future without paying something, but OQI initiatives, when they come, they are very positive things, that we should not worry. These things will still be available to us on the cloud. Transition is always, challenging. It is not like this that it is not challenging.
Yes, sir.
When I started my career as a physics student, I think we never had this inclination that we will have even computers on our table. Everybody used to talk about mainframe computers, and those were not accessible to everybody.
Yes,
There was no web that you can log in from somewhere and do things there. But once personal computer came, Microsoft brought in a small diskette called DOS. In that, they had ported a small computing language called BASIC. And I think people started using it. We in physics used to say, oh, you should work in Fortran. And we were finding that the compilers of Fortran were very costly. But then slowly and steadily we moved. We find that the DOS was changed to a very interesting environment in the open source called Linux. Linus Torvalds actually brought that change, and that was a free kind of an operating system. When you needed something to buy from Microsoft, you had to pay, but the Linux is free. And slowly and steadily, even for doing computational computing like electronic structure calculation, we know that unless we found that open source codes are available, we were not able to use them even on the computers which were available to us. And this computing power has increased tremendously. On my mobile itself, I can open more than 30 windows at the same time and still look at those things. There was a time when on a Windows platform, if we open 3 windows, we will find that system will crash. We have overcome all those things. And the coming of this quantum computing to solve these complex problems is a very positive thing. Initiative is very positive. What I am trying to say, particularly to the young students who are sitting in this audience, is this, that please feel free to not only study physics in the classroom, but beyond the classroom also. The link which I mentioned is one such link where you can go and systematically find free courses are available to learn all these things. And I would encourage people to talk about these things. Look, chemistry walas, social sciences, physics wala, mathematics walas, they have to come together and talk with each other. And then only then such complex problems can be solved. Otherwise not. So it is a kind of a situation which is waiting for solutions. Hopefully, we will also benefit not only in terms of using it, but in also finding job opportunities in it. I think that is something which we need to convey very strongly to our students.
Thank you, sir. I request participants, if you have any doubts, you can interact with sir.
You can ask questions also if you feel like. I may not have an answers, but still I would love to hear questions. You can write in the chat box also. Yeah.
So if there are no questions, I request my colleague Dr. Devi to propose vote of thanks, and meanwhile I'll share the feedback form in the chat box and request participants to fill to get your e-certificate. Yeah, over to you, Devi.
Good evening. I am Dr. Devi, as Assistant Professor, Department of Physics, St. Francis College for Women, take this opportunity to propose the vote of thanks. I express my sincere gratitude to Dr. P.K. Ahluwalia, National President of IAPT, former Professor, Department of Physics, Himachal Pradesh University, Shimla, for graciously sparing his valuable time and delivering an enlightening lecture on quantum science for sustainable tomorrow. Dr. Ahluwalia elaborated on OQI, highlighting its mission to connect quantum science and technology with global challenges. Sir also discussed quantum computing and its transformative potential in solving complex problems for sustainability, technology innovations, and societal development. Sir, your vast experience and inspiring insights have greatly enriched this program, celebrating the year 2025 as the International Year of Quantum Science and Technology. Thank you very much, sir. I also sincerely thank Dr. C.H. Madhusudan, Assistant Professor and Head Department of Physics, Government Degree College, Siddipet, and President IAPT RC22 for his encouragement, support in organizing this academic event. I extend my gratitude to IAPT RC22 for their cooperation and for promoting physics education through such meaningful initiatives. I express my heartfelt thanks to the management of St. Francis College for the support and cooperation in hosting this program. I also thank all the faculty and students for their enthusiastic participation and keen interest, making this session truly engaging and successful. Once again, I thank everyone who has directly or indirectly contributed to the success of this guest lecture. Thank you all. Thank you, sir.
There is one question which has come. May I respond to that in the chat
Yes,
box?
sir. Yes, sir. Sure, sir.
This is from Satvika Chila. Good evening, ma'am. And the question is, also there is another question from G. Swarna Latha. So I will take ma'am Swarna Latha's question first. In future, how quantum physics will rule us? You know, quantum physics is already ruling us. We should not forget that. It's already there. But you know that coming of quantum physics in the form of these new 21st century quantum revolution 2.0, I think whenever such thing happens, it not only rules us, but also serves us. What I showed you in today's presentation was that how this is going to serve us in solving the problems of the society itself. And this is a very important thing. And I think that is what I can say. Ruling is a very interesting word. How it is going to rule us means as if it is going to dominate us. I think every technology has its advantages and disadvantages. Even mobile has so many disadvantages. We are talking about that a lot. But then if you start saying that this is coming from quantum mechanics involved in making the mobile, I think that will not be the right approach to look at things. We have to really use our, sincere thinking and thoughtfulness to make sure that we make use of this for the best advantage. The second question is, how can quantum technology help countries use resources more efficiently? I think I mentioned in one of these case studies itself, resource management. How are we going to do resource management? How are we going to manage our forests? How are we going to manage our river water, which is again very, scarce. It is not too much with us. Fresh water is not very largely available, but I think these are the possibilities which can help us looking at all these things very, very efficiently. Coming off solar energy, for example, has helped us saving our resources a lot. Then another question is by Navya Sri. Given the power of quantum computing, what do you think is the biggest ethical issue that we might face? Ethical issues are very similar. Given the power of a nuclear bomb, the ethical issue is how we make use it for benefit of the mankind and not for the destruction of mankind. Similarly, whenever any quantum technology is going to be there, we have to make sure that it is used for the benefit of the mankind and not otherwise. For example, one of the dangers which we are talking about quantum computers is that our ordinary passwords may not really work when quantum computers come into force. So maybe we'll have to switch over to quantum cryptography, where we will find it very difficult to hack the passwords also. Now, Dr. Shikha Chandra from chemistry is saying that how can it help in docking and water management? You know that the biggest challenge is that once the water gets polluted, we know that there is a pollutant. And this pollutant is, if we try to go deeper into it, is like a molecule. Can we really dock another molecule which can break it and destroy it? Means so that we can get this pollutant material out of the cycle of the water itself? Answer is yes. Solutions are there right now, but I think what quantum computing is going to do is it will bring some kind of an accelerated effort in that particular direction. And I think this is a very big issue in our own country itself. So I think these were the 3-4 questions which were there. I hope I have been able to give some answer. It is a very interesting field. Hopefully, there will be more talk, ma'am, in your college among students about
Yes,
it, and they will start seeing some due advantage in the near future. So, thank you.
Thank you so much, sir, for your time. And we are very happy that we have been involved in this session. There are so many takeaways. Hope our students work towards it. Maybe it as a project, mini project, and whatever websites you have shared. Thank you so much. And I personally thank Dr. Madhusudan for all your support and encouragement, sir. Without IAPT RC22, this session wouldn't have been complete. And I have been trying for this session since the announcement of United Nations that International Quantum Year has to be celebrated. So from that time, I have been looking for it. Hopefully, we could do it at the end of the flag end of the year, sir. Thank you so much, sir.
And this is not the end of the story, it is the beginning of the story. We should
Exactly,
continue
sir.
with these initiatives in the near future
Yeah.
also.
Hopefully, sir. Thank you
Yes,
so much, sir.
yes. Thank you. So, thank you very much.